Chain rule of differentiation, shortcut version. So in the first lecture of the chain rule of differentiation, we have explored the detailed working, how we apply the chain rule by applying the method of substitution. In the present lecture, we will go for the shortcut version, that is, we will see how we can apply the chain rule of differentiation mentally without much working, and what we prefer in this subject, in the subject of physics, we would like to apply the chain rule mentally, that is the shortcut version. Okay. So the prerequisite for this lecture is that you must be knowing the basic derivatives, like the derivative of x power 5 is 5x power 4, the derivative of sin x is cos x, root x has a derivative of 1 by 2 root x, ln x has a derivative of 1 by x, Euler's number natural exponent, e power x is derivative is e power x. Okay, that is the prerequisite for this lecture. You must be knowing the basic derivative formula. Now let's see the roadmap, how we will proceed in the present lecture. While applying the chain rule, we will identify the base function. What is the base function and what is the argument of the base function? As you proceed in the lecture, you will come to know more clearly what I mean by base function. So we'll see different types of base functions, like algebras, where we'll be doing the derivatives of expressions like this: 5x minus 9 whole index 3 under root 4x cube minus 5x square plus 5, so on so forth. Okay, so this will be the first type of differentiation where we will learn how to apply the chain rule mentally. Then we'll see the types of trigonometric functions, like y is equal to sin 5x minus 2 cos root 4x plus 2, so on so forth. Then we will explore the variety of exponential function, more precisely natural exponent, e index of something like these functions, and then we'll see the logarithmic functions like ln 5x square minus 3x, ln sin x. Okay, so we'll see there are variety of expressions which can be solved very easily by applying the shortcut, or you can say the mental approach of the chain rule of derivatives. After that, we'll see some complex functions where it will be the combination of different functions like the algebraic, trigonometric, exponential, like this y is under root some exponential function, we are adding some sine function, then some polynomial, or y is equal to ln sin square x. And once you learn how to apply the chain rule mentally, all these things will be quite easy for you. You can do all these such kind of derivatives within a couple of minutes, or even less than couple of minutes. Okay, so note the heading, base. Here we are taking the base function as an algebraic function. Okay, so we know the standard form. If y is equal to x index n, where n is of course some real number, then we have seen in the basic lecture of derivatives, dy by dx is what? Nx power n minus 1, correct? So suppose we have y is equal to x power 5, then we know what is the formula for dy by dx. So here it is of the standard form, x power n. So we can apply this formula. You will get 5x 5 minus 1 4. Okay, so there is no need of chain rule in such standard forms, correct? There is no need of chain rule in such standard forms. They can be differentiated directly using the standard formula. Now suppose we have something like this: y is equal to 5x minus 9 whole power 3. Now this is not in the standard form of x power n, because in the standard form x must be alone. There is no coefficient of x, number one, and number two, there is nothing added or subtracted with x. So this is of course not the standard form, so we cannot directly write the answer. The answer will be 3 5x minus 9 2. Okay, so here we will apply the chain rule. Now see, in this function, this we can say this is the base function. This whole thing is the base function. Okay, and this is called the argument of the function, or you can say the inner function. In simple language, you can say inner function. Okay, now just think, had it been instead of 5x minus 3, had it been y is equal to u power 3, then we could easily find dy by du. Here we can find dy by du, not dy by dx, because y is u index 3. So dy by du would be 3u2, correct? Because this is a standard form, you can directly apply the differentiation formula. But in the present problem, we have 5x minus 9. Instead of u, we have 5x minus 9. Now, when you mentally apply the chain rule, what you need to do, hold the argument as a single quantity. Listen carefully. Treat the argument as a single quantity and differentiate the function. So if I'm treating the argument as a single quantity, okay, suppose I have y is equal to 5x minus 9, 3, and this is the argument. So this is treated as a single quantity, okay, and differentiate applying the standard formula. So we'll get dy by dx as what? So if this is a single quantity like u and has a power 3, so we'll have the formula n, that is 3, that quantity which is treated as a single quantity, 5x minus 9, and 3 minus 1, that is 2. Okay, this is the first step. The answer is not complete. This is simply the first step. So what you did, you are differentiating the base function, treating the argument as a single quantity, correct? You are differentiating the base function, treating the argument as a single quantity. Now what you need to do, you have to form the chain. Multiply it with the derivative of the argument. Now go into the argument, or in the simple language, go to the inside function. Okay, go to the argument, or in the simple language, go to the inside function, inner function, and differentiate that argument or differentiate that inner function. So we have to differentiate this thing, 5x minus 9. So the derivative of 5x is 5 and the derivative of 9 is 0. So simply it will be 5. Now you can write the 5 into 3 will be 15 and we'll get 5x minus 9 index 2. So this is your final answer. Got it? Now let's see the second illustration. Say y is equal to 7x cube plus 2x square plus 9x minus 5 whole power 5. So again we have something of this form. Say y is something to index n, and whenever form you can treat this something which is the argument as a single quantity. And this something is 7x cube plus 2x square plus 9x minus 5, and the power of something is 5. So if you apply the chain rule mentally, you'll write dy by dx is what is the power? 5. Write the something intact without disturbing that something. You have simply to copy it. You'll get 7x cube plus 2x square plus 9x minus 5. Now apply the basic formula. So this is n, the power will be n minus 1, 5 minus 1 will be 4. And then we will form the chain. We have to multiply with what? The derivative of the argument. So the derivative of 7x cube will be what? 21x square plus 4x plus 9, and 5 has a derivative 0. So this will be the answer. Okay, this will be the answer for dy by dx. I'll give you more illustrations so that in the application. Are you clear with the format? You have to observe that y is given as something to some index. Something to some index. That something is the argument, and you have to apply the formula n something n minus 1, then you have to multiply with the derivative of that something or argument. Got it? See, now if you are writing in some mathematical sophisticated form, so say we have a function of this form, y is some function of x with some index. Okay? Now dy by dx will be what? So this thing, this something will be written as it is. So n, that function, index n minus 1. This is the first step. Now you have to multiply it with the derivative of f of x. And we know how we write the derivative in mathematics, f dash or f prime x. Got it? And this f of x can be anything. It can be the algebraic function, it can be the trigonometric function, it can be the exponential function, anything. Okay, so this is the basic of the chain rule in this form of the function, when you have function to some index. Simply apply the basic formula for the function, then multiply with the derivative of the function. Now let's see some more illustrations. See, here we have three illustrations. Find dy by dx. So a is given as y is equal to 3x minus 5 power 3. So we have something to some power. So we'll apply that formula dy by dx. Write the power 3. Same thing, no change. Power minus 1, 2 multiplied by derivative of this thing, argument. So 3x, here something is this. So 3x will have a derivative 3, 5 has a derivative 0. Your answer will be 3 into 3, 9. 3x minus 5 square. This will be your part. Okay, now let's see part B. Y is equal to 5x square minus 7x plus 9, 3 by 2. So is it of the form some function or something or the argument to some index 3 by 2? So we can apply that as standard form chain rule. So dy by dx will be what? Think. So here the index is 3 by 2, the power is 3 by 2. So we'll write 3 by 2, copy it, that argument, the function or something, whatever you might like to say. So we'll get 5x square minus 7x plus 9, decrease the index by 1. So 3 by 2 minus 1 will be 1 by 2. Now you have here you need to multiply with the derivative of this argument. So derivative of 5x square is 10x. 7x has a derivative of 7, 9 will have a derivative 0. So this will be your answer for part B. Got it? Okay, now let's equal to under root sin x. Got it? So we have something, and that something is sin x here in the root. We know the basic, if y is root x, dy by dx comes to be 1 by 2 root x. Okay, this we have seen in the fundamental lecture of basic differentiation. We will apply the chain rule. So dy by dx will be, forget what is inside the root. We need not to take care of what is inside the root. Simply write 1 by 2 root sin x. Write that something as it is, intact. Now we have to multiply with the derivative of that argument. Here the argument is what? Sin x. So the derivative of sin x is cos x. So your answer will be cos x by 2 root sin x. This is your answer. Got it? So here the chain rule. Now let's see some further illustrations. Find dy by dx. A is y is equal to ax minus b whole cube. So here again identify the base function. So this is the base function. You have something to some power. So you will apply the basic formula 3. Copy that something, that argument ax minus b, decrease the power by 1. 3 minus 1 will be 2. Now you have to multiply with the derivative of the argument. Ax will have a derivative a and b will have no derivative, 0. Being a constant, a and b are constants in this case. So we'll get 3a ax minus b square. This is your answer for part A. See part B. Y is equal to a minus bx whole square plus cx cube under root. Now we have to find dy by dx. So we know the basic root x has a derivative of 1 by 2 root x. And whenever you have root of some complex function, forget what is inside the root. Simply first apply the derivative formula for the root. Remember? So whatever is inside the root, that is the argument. Whatever is inside the root, this thing. This is what? This is the argument. So you remember step 1 in the, you have to differentiate the function treating the argument as a single quantity. So we know derivative of root x is 1 by 2 root x. That is the FTP basic formula, fingertip point FTP. So this thing will have a derivative of 1 by 2 a minus bx square plus cx cube as it is. Now we have to form the chain. So we have to multiply this quantity with what thing? We have to multiply it with the derivative of the argument. We have to multiply it with the derivative of the argument. So first we have to find the derivative of this quantity, the first expression a minus bx whole square. So here also we have to apply the chain rule. So a minus bx whole square will have 2, this thing, a minus bx, 2 minus 1 will be 1, and there is no need to write 1. And then we have to differentiate this thing, a minus bx. So what is the derivative of a? 0. Minus bx will have a derivative, minus b. Here I am putting the bracket. Now I have to find the derivative of cx cube. So cx cube will be 3cx square. So this will be your answer, correct? So therefore dy by dx comes to be, you can write minus 2b a minus bx plus 3 cx square divided by 2 a minus bx square plus cx cube. Okay, this will be your final answer. If you see some such types of expressions, suppose we have y is equal to a minus bx, say 5 plus c root x, and whole thing in under root, and we have to find dy by dx. So again the same thing, you will start from the very basic base function. This whole thing is the under root, and whatever is inside the under root, treat it as a single quantity argument. So apply the formula for differentiation of the root. So you'll get 1 by 2 root copy, same thing, b minus bx 5 plus c root x multiplied by, come outside, multiply this thing with the derivative of the argument. So first you will differentiate this thing, and again you will apply the chain rule. So it has a power of 5, a minus bx, 5 minus 1 is 4, multiplied by derivative of this. So a will have a derivative of 0, minus bx will have a derivative of minus b, plus c will remain c, and derivative of root x is 2 root x. So this will be your final answer. If you want to make it sophisticated, you can write it like dy by dx is minus 5b a minus bx 4 plus c by 2 root x divided by 2 a minus bx 5 plus c root x whole under root. Okay, this is your final answer. Now let's see some more illustration. A is y is equal to 1 by 3x square plus 7x whole power 3. We can bring it in the numerator. So we'll get 3x square plus 7x minus 3. So you get this function, we have something to some index. So therefore dy by dx will be the index minus 3, the same thing, the same argument, minus 3 minus 1 into derivative of the argument. So you'll get 6x plus 7. This will be answer. So you'll get minus 3, 3x square plus 7x, and that will be minus 4 into 6x plus 7. That is your final answer. Write it with the positive index. You can bring it in the denominator. So you'll get minus 3, 6x plus 7 divided by 3x square plus 7x index 4. That is your answer. Got it? Okay. Part B, similar types we have done in the previous illustration. Y is equal to a minus bx whole square plus c minus dx whole square whole under root. And you have to find dy by dx mentally, shortcut version. So this is in the root, so this will be treated as a single argument. So I'll get 1 by 2, write the same argument, a minus bx square plus c minus dx square. Now we will multiply with the derivative of this, what is inside the root. argument, forming the chain. So we'll get, again we will apply the chain rule for this expression. So the power is 2 a minus bx, the derivative of a will be 0 minus bx will have a derivative of minus b, and you will have plus 2 c minus dx, the derivative of c will be 0 and minus dx will have minus d derivative. So this will be your answer. You can plot the common factor 2. So you will get minus b a minus bx minus d c minus dx divided by a minus bx whole square plus c minus dx whole square whole under root. That is your final answer. Got it? So I guess you by now you must be very much clear how to apply the chain rule when you have the expression, something which you call as the argument raised to some power. So you can apply the chain rule. Got it? Power multiplied by that something, whatever is given, to the index power minus 1, and then we will differentiate that something, we will differentiate that argument. Okay, now let's see the second type of functions, which are the trigonometric function, how we will apply the chain rule. The basic standard form which we did in the basics, sin x has a derivative of cos x, cos x has a derivative of minus sin x, tan x has a derivative of sec square x, and cot x has a derivative of minus cosec square x. So these are the standard form, and in these standard form, this angle of the trigonometric function is called the argument. Okay, so if the argument is a single variable, there is no need to apply the chain rule. You can simply apply the direct standard formula, correct? But if the argument is complex, something like this, say we have sine 3x square plus 7x minus 9. Now this is the argument which is not equal to x. So this is, here you cannot apply this formula. Or suppose we have cos under root x. So this, here you cannot apply that formula because this is not x. This is under root x. Okay. And suppose we have cos 5x square minus 7 3 by 2. So here you cannot apply this formula. So for these kind of expressions we can have what? The chain rule. Got it? So see what we will do in this case. Suppose we have, now let's see what we will do in these cases. Suppose we have y is equal to sine f of x, and this f of x is the argument, or you can say the inner function. Okay, argument or the inner function. Now when you differentiate, forget what is in the argument. Treat the argument as a single quantity. Remember the golden rule with which we started the lecture. Treat the argument as a single quantity. Keep it intact. Do not disturb it and differentiate. So had the argument been a single quantity, so the derivative of sine would be cos, correct? So you will have dy by dx will be equal to cos of f of x. We won't disturb the argument, same thing. Now form the chain, multiply with the derivative of the argument, that is f prime x. F prime x is the notation for the derivative of f of x. Okay, now let's see some illustrations. Suppose you have y is equal to sine 3x plus 5. Of course, this is not the standard form where we can apply that formula, because in this case the argument is 3x plus 5, not x. Had it been x, simply the answer would be cos x. But here it is 3x plus 5. So treat the argument as a single quantity and write dy by dx. So the derivative of sine is what? Cos. Copy the argument. Now multiply with the derivative of the argument. So what is the derivative of the argument? So 3x will have a derivative 3 and 5 will have a derivative 0. So multiplied by 3. And to make sure that 3 is multiplied with this whole thing, 3 is not the multiplication with the argument. So to avoid such confusion, what we can do, we can write transport 3 on the left hand side outside. So I can write 3 cos 3x plus 5. This will be your answer. Got it? The first illustration. Okay. Let's see some more illustration. Suppose I'm writing y is equal to cos 4x square minus 5x plus 9. Okay. So had it been cos x, then the answer would have simply been minus sin x, because cos x is something where you can apply that standard formula. But here the angle of cos or the argument of cos is not x. It is 4x square minus 5x plus 9. So this is a argument. So dy by dx, we will apply the rule. We will differentiate the function treating the argument as a single quantity. So the derivative of cos is sine. Copy the argument 4x square minus 5x plus 9. Now you have to form the chain with what? The derivative of the argument. So 4x square will have a derivative 8x, 5x will have a derivative 5, and 9 will have a derivative 0. So this will be the answer. So your answer will come to be minus 8x minus 5 sine 4x square minus 5x plus 9. This is your final answer. Got it? Now let's see some of the illustrations. In this case we have a, y is equal to sine 5x. So this is the argument. So when you write dy by dx, treating the argument as a single quantity, we know the derivative of sine is cos. So you will have cos 5x, then you have to multiply with the derivative of the argument, and the derivative of the argument 5x is what? 5. And 5 will be transported outside to avoid confusion that 5 is not multiplied with this 5x. So I'll get 5 cos 5x. This is the answer for part A. Now see part B. I guess part B you can do yourself, and what I suggest, make the video still for 1 minute, work out part B, and then check out the answer with mine answer. Okay. So here this is the argument. So dy by dx will be what? The derivative of sine is cos. Copy the argument multiplied by derivative of the argument. So we'll have 6x plus 5. Bring it outside. You'll get 6x plus 5 cos 3x square plus 5x minus 6. That is your answer. Got it? Okay. Now let's see some more illustration. Y is sine root x. So this is the argument. So dy by dx will be simply the derivative, treating the argument as a single quantity. So derivative of sine is cos root x. Now we have to differentiate the argument. And what is the argument? Root x. So what is the derivative of root x? 1 by 2 root x. And this quantity can be taken outside. So I'll get 1 by 2 root x cos root x. This is the answer. Now say part B. Y is equal to tan x square. Now what is the argument? X square. Treat the argument as a single quantity, and the derivative of tan is what? Sec square. So you'll get sec square, copy the argument, no disturbance with the argument, no tampering with the argument, multiplied by derivative of the argument. So x square will have a derivative 2x. So answer will be 2x sec square x square. This is the answer. Got it? Okay. Now see some more illustration. Y is equal to cos under root ax plus b. Now you can see the angle of the cos is the argument. So this is the argument. We will apply the chain rule. So dy by dx will be the derivative of cos is minus sine, copy the argument, multiplied by, we have to multiply it by with the derivative of the argument. So root has a derivative of 1 by 2 root of same thing ax plus b. Now again we have to apply the chain rule, because inside the root there is not x. Had there been x, we would have terminated here. So the derivative of ax is what? A, and the derivative of b is what? 0. So your answer will be, you can bring minus a by 2 ax plus b sine ax plus b under root. This is your final answer. If you see this part B, y is equal to cos ax square plus bx plus c. Now this is the argument. Cos as a derivative of minus sine. Keep the argument intact, copy it, take the chain, multiply with the derivative of the argument. So ax square will be 2ax, bx will be b. So your answer will be minus 2ax plus b sine ax square plus bx plus c. That is your answer, final answer. Got it? Okay, now let's see the type 3, the natural exponential function. So we have seen in the basic differentiation, if y is equal to e index x, e is the natural exponent base, Euler's number, then dy by dx is what? Same thing, e index x. That is something we covered in the basic lecture of derivative. Okay, now suppose you have something like this, e index 5x, e 3x square plus 9, e index sin x, e index root x. So these are not in this form, correct? If you see all these exponential function, they are not of this form, not meeting this criteria, because here the power is simply x, and this is called the argument. This quantity, the power, is called the argument of the natural exponent. So if we have to differentiate these kind of expression when the power is not x but something else, so we cannot apply this formula. We have to apply the chain rule. Okay, and chain rule says whatever is the argument, treat it as a single quantity and differentiate. So e power f of x's derivative will be e power f of x, same thing. Now we will form the chain, we will multiply with the derivative of the argument. This is the chain rule, correct? Treating the argument as a single quantity, differentiate the function, and then whatever is coming, multiply it with the derivative of the argument. This is what the chain rule we have. So see the first very basic illustration. If y is e power 5x, here the argument is 5x. That is not x. Had it been x, there is no rule of chain rule. We could simply write e ki power x, e power x will have a derivative e power x. Now here you have to find dy by dx. So treat the argument as a single quantity. So you'll get e 5x. Now multiply with the derivative of the argument. So 5x has a derivative of 5. So your answer will be 5e 5x. This is your answer. Got it? This will be your answer. Now let's see some of the illustrations. This already I did. Say b, y is equal to e power minus cos x. So here the argument is minus cos x. So treat the argument as a single quantity. The e power of something will have a derivative of e power of same thing, correct? Now multiply it with the derivative of the argument. So cos x has a derivative of minus sin x, and one minus is already there, so you will have this thing. So your answer will be minus into minus will be plus sin x multiplied by e index cos x. That is your answer. Got it? See, whatever you are doing, you are simply writing e power of same thing. Then you are differentiating the power. Power means the argument. Now see this illustration A, y is equal to e 3x square plus 4x minus 9. So in this case, I guess this is the argument. So dy by dx, it will be e to the power same thing. So we'll get e 3x square plus 4x minus 9 multiplied by the derivative of the argument. Now you have to multiply with the derivative of argument. So 3x square will have a derivative 6x, 4x will have a derivative 4, 9 will have 0 derivative. So your answer will be 6x plus 4 e 3x square plus 4x minus 9. Now say B, y is e 3x minus 5 under root. Now here if you see the index of e, if you see the power of e, that is root of something, 3x minus 5. So this thing is the argument. So dy by dx is simply same thing, e to intact argument multiplied by, now we will multiply with the derivative of argument, correct? So the derivative of root is 1 by 2 root of some same thing. So 2 root 3x minus 5. And still you see, had it been x, we would have been terminating here. But inside the radical we have 3x minus 5, which is not the standard form. See, we have to decide where we have to terminate the chain. This is also of critical point. You have to decide where you will stop the chain. So when you reach the standard form, the chain will be stopped. But here if you see, inside the root we have a linear function which is not x. So we have to multiply with again the argument of this root. So 3x minus 5 will have a derivative of 3. 5 will have no derivative, 0. So your answer will be 3 by 2 e 3x minus 5 root power in the numerator and 3x minus 5 root whole in the denominator. This is your answer. Got it? Okay, now let's see. We have seen algebraic form, we have seen the trigonometric form, we have seen the exponential form. Now let's see the logarithmic form. Now we know the natural log. If y is equal to ln x means log of x to the base e. This is called the natural log. So dy by dx is what? 1 by x. This we did in the basic standard lectures. This is the standard formula for the derivative of ln x. Suppose if we have expression something like y is equal to ln 3x, y is equal to ln 5x square minus 7x. This is called the argument in this case. Okay, this is the argument of the log function. So y is equal to ln sin x. So here the argument is not x but 3x. Here the argument is not x but 5x square minus 7x. Here the argument is not x but sin x. So here we cannot apply this standard formula. We have to apply what? The chain rule. Okay? Because remember, chain rule will be called upon when we have the argument which is not meeting for the model of the standard formula. Had the argument been x, simply we would write 1 by x. So same rule of the chain rule. Suppose if you have, first I am writing you the format, mathematical form. Y is equal to ln f of x, and this is some function of x, any function, maybe algebraic, maybe trigonometric, maybe exponential. So dy by dx will be what? This is the argument, correct? So differentiate the log function treating argument as a single quantity. So ln x has a derivative of 1 by x. So ln f of x will have a derivative of 1 by f of x. Now we will form the chain. We will multiply with the derivative of the argument. That is the basic of the. Say, if you have y is equal to ln 5x square plus 7x minus 9, and we have to find dy by dx. So what is the argument in this case? Can I say this? This is the argument of log. So treat it as a single quantity. So you'll get ln x has a derivative of 1 by x. So ln something will have a derivative of 1 by same thing. Keep the argument intact, no change in the argument. Now form the chain. Multiply it with the derivative of the argument So 5x square will have a derivative of 10x, 7x will have a derivative of 7. Correct? So you will have the answer 10x plus 7 divided by 5x square plus 7x minus 9. That is the answer. Got it? So whenever you have ln of something, so first write 1 upon that something, then multiply this result with the derivative of that something. Okay? Let's see some of the illustration. A, y equal to ln 2x minus 1. Now this is the argument. Keep the argument intact and differentiate log. So I'll get 1 by 2x minus 1. Now multiply with the differentiation of the argument. 2x will have a derivative of 2. So answer will be 2 by 2x minus 1. This is the answer. Got it? Okay, now say part B. Y is equal to ln sin x. So here sin x is the argument. Sin x is the argument. So dy by dx is, the derivative of ln is 1 by the argument of ln, that is sin x. Okay, now we have to differentiate this thing. Had it been x, we would have stopped here. But this is not x, this is sin x. So we have to multiply with the derivative of sin x, that is what? Cos x. So your answer is cos x by sin x, which can also be written like cot x. Got it? Okay, now let's see. We have seen how we work out with the chain rule in the form when y is equal to something to the power n, when y is equal to sine, cos, tan, all this with some argument, when y is equal to e index something, when y is equal to ln something. Now when we will have the combination of many functions, so you have to apply the chain rule and may the steps need to be repeated. Okay, like these functions say. So in such application of chain rule, you have to be very clear how you are forming the chain. That is, first you will identify the base function, then the argument, and then the argument will be acting as a base function. Okay, like say, if I am writing y is equal to 3x, sine of 3x square minus 5x plus 2 whole under root. Now if you want to apply the chain rule, so first of all you need to decide which is the first base function which need to be differentiated. So the first base function is sine. Okay, and this thing is the argument. If I am writing in some steps, so I'll write cos, copy the argument, 3x square minus 5x plus 2 under root multiplied by now derivative of the argument. So see here I'm writing some steps like d by dx of 3x square minus 5x plus 2 under root. So you'll get cos 3x square minus 5x plus 2 under root multiplied by, now we have to differentiate this thing. Here also we need to apply the chain rule as we have seen earlier. So the derivative of root is 1 by 2 root 3x square minus 5x plus 2 multiplied by the derivative of the argument, that is 6x minus 5. So this is the final answer, which you can write like this: 6x minus 5 divided by 2, 3x square minus 5x plus 2 multiplied by cos of under root 3x square minus 5x plus 2. This is a final answer. See. So see how the links of the chain are formed. Can you see how the links of the chain are formed? First you have differentiated sine. Then you have differentiated root. Identify the base function and the argument as the first link of the chain. Identify the base function and the argument as the first link of the chain. Here the first link of the chain, the base function is sine, the argument is this root. repeat the steps forming a chain. Now you need to repeat the steps until the chain is terminated, until you get a standard form. So when the chain will be terminated, when you get the standard form in the argument. So the base function is sine, so we'll differentiate sine treating the argument as a single quantity, correct? You will differentiate sine treating the argument as a single quantity, then you will differentiate argument. And while differentiating argument, it is possible that you have to again apply the chain rule, okay? Now let's see some of the illustration. Y is equal to sin x plus cos x whole index 3. Now again the same thing, first of all you need to identify what will be the first link of the chain. So if I am treating this as a argument, okay, this is the argument. So you have argument to the power something. So you remember the standard form. This will have 3, same argument. 3 minus 1, 2. Then you have to multiply it d by dx. I am writing right now d by dx. Once you get fluent, there is no need to write this thing. Of sin x plus cos x. So you will get it 3 sin x plus cos x 2. Now what is the derivative of sin x? Cos x. And what is the derivative of cos x? Minus sin x. So this will be your answer. Got it? Okay, now let's see. Y is equal to under root cos this thing. So we have the base function as the root. Root is the base function. And this is the argument. So dy by dx is first differentiate the root. So 1 by root has a derivative of 1 by 2 root of same thing. So you'll get cos 3x plus 1. Now you will form the chain d by dx of whatever is inside the root. Cos 3x plus 1, correct? Now see, this will be 1 by 2 cos 3x plus 1. And here also you have to apply the chain rule. So cos will have a derivative of minus sine 3x plus 1, remember? And 3x plus 1, the argument is still 3x plus 1. So we have to further apply the derivative of the argument. So 3x will have a derivative of 3. So your final answer will be minus 3 sine 3x plus 1 divided by 2 cos 3x plus 1 under root. That is your final answer. Got it? Now let's see. Y is e power sine ax plus b. Now the base function is the natural exponent function and this is its argument. First link of the chain. For no matter how complicated the function may be, you have to identify what is the first link of the chain. The base function and the argument. Here the base function is the natural exponent and its argument is what? Sine ax plus b. So dy by dx will be what? E, copy the argument, remember? Sine ax plus b. Now we have to further multiply it by the derivative d by dx of sine ax plus b. This is the chain rule. So you will get e sine ax plus b multiplied by, we'll have cos ax plus b, and here again we have to apply the chain rule because this is not the standard form. So the derivative of ax is a and the derivative of b is 0. So your answer will be a cos ax plus b multiplied by e index sine ax plus b. That is your final answer. Got it? Now see, y is equal to sine 3x plus tan x. So forming the first link of the chain, this is the base function and this is the argument. So dy by dx, the derivative of sine is cos, copy the argument. Now we have to multiply it with the derivative of the argument, that is 3x plus 10x, correct? So you will get cos 3x plus tan x, and the derivative of 3x is 3 and tan x has a derivative of sec square x. So this will be your answer. You can bring it here on the left side to avoid the confusion that it is being multiplied with the argument. So you'll get 3 plus sec square x cos 3x plus tan x. This is your final answer. Got it? Okay, now let's see y is equal to sine cube x. So y is equal to sine cube x. So it can be written like sine x whole index 3. Now which form you can see here, this is the base function, this whole thing is the base function, and this is index. So remember, when base, some argument has some index, so dy by dx will be 3, the same base, the same argument, that is sin x, and you will decrease the power, it will be 2 into d by dx of sin x. So you'll get 3 sine square x, and the derivative of sin x is what? Cos x. So this is the answer. Clear? So I guess by now you must be clear how you apply the chain rule, no matter how simple the function and how complicated the function may be. Now after this lecture, what I suggest, you can attempt the related DPP, which will have plenty of problems, so that it will make you fluent. It will give you a ample amount of practice what you have learned in this lecture, and you can check the answer, and then after the DPP you can attempt the online test on a portal to see, to test yourself, to evaluate yourself how fluent you got in the skills of the chain rule. Got it?